In this problem, we will use A for the first term and D for the common difference of the arithmetic series. The sum of the fifth, sixth, and seventh terms of the series is equal to 9 times the sum of the first and second terms. This gives us a linear algebraic equation. Simplifying the equation, we find that 2D is equal to 5A. The third term of the series is 12. By substituting 2D equals 5A, we find that 6A equals 12. This means the first term, A, is 2. We can use this value to find the common difference, D, which is 5. The general formula for this series is A plus the product of n minus 1 and D. Using A equals 2 and D equals 5, the general term UN becomes 5n minus 3. Next, we need to find the summation from the 15th to the 60th terms. In this summation, the first number is 72, and the last number is 297. The number of terms is 46. We use the formula n over 2 times the sum of the first and last terms to calculate the summation. Solving the expression gives 8,487, which is the summation from the 15th to the 60th terms. Now, we need to find the value of n from the given equation. Since un equals 5n minus 3, 5 times un is 25n minus 15. The formula for the sum of the first n terms, Sn, is n over 2 times 2, a plus n minus 1 times d. Substituting a as 2 and d as 5, we find that Sn equals n over 2 times 5n minus 1. Doubling both sides, we get 2 times Sn equals 5n squared minus n. Substituting these values into the given expression and simplifying the equation, we obtain 5n squared minus 26n plus 5 equals 0. The quadratic expression can be factorized as 5n minus 1 times n minus 5. Since n must be an integer, we take n minus 5 equals 0, which gives us n equals 5.